The octet rule is the single most important rule in the bonding of main group atoms, and it was first introduced by Lewis of Lewis structures, but it has a peculiar history. It took actually an enormous time. Lewis introduced the idea of the octet 100 years ago, but it really wasn't until around 30 years ago that it became completely clear, self-evident to chemists, that the octet rule was obeyed whenever it can be by main group elements. And actually, the person most responsible for setting back, I don't know, by 70 years our understanding of the importance of the octet rule was Linus Pauling. One consequence of the enormous amount of time it took that the octet rule to be developed is that your textbook, which was written a few years ago, is completely out of date, and it should not be trusted for its Lewis structures. Just use what I'm teaching in class, and the authors of the textbook, two of them have passed away, so they cannot revise their book. So just use the Lewis structures that we're teaching in this class. Okay, so what is the octet rule? The octet rule first is obeyed by main group atoms that are not the metals, shown in green. The ones shown in pink, those are metals, and they don't particularly obey the octet rule. And there are a few elements that are sort of halfway between metals and nonmetals: beryllium, boron, tin, bismuth, and polonium, and they sometimes obey the octet rule. So that's one proviso. Let's look at water. There it is in the circle picture. There is in the Lewis structure. One pair of electrons shared between two atoms lead to a single bond. And the concept that we're going to need is formal charge. Formal charge, remember, is the process by which electrons in the bonds get shared equally between the two electrons. So oxygen ends up with how many electrons after in the formal charge count? Look at the picture on top, put it in chat. Oxygen ends up with 6 electrons, and it starts with, put in chat how many? 6 electrons, and therefore its formal charge is 0, which is also called neutral. And hydrogen similarly is neutral. Let's look at these 4 important molecules. The first, the one involving carbon, is methane. It ends up with what formal charge? And well, carbon ends up by formal charge with 4 electrons, and it had initially 4 electrons, so its formal charges, put it in chat. Put it in chat. 0. Let's look at nitrogen. Nitrogen in ammonia, shown in black there. Its formal charge is, well, it ends up with how many electrons by formal charge? 5. It starts with 5. Its formal charge is 0. We did already water. Its formal charge, the oxygen formal charge is 0. And in FH, the formal charge is 0. And if you look at those 4 elements, carbon, nitrogen, oxygen, and fluorine, you can see that there's a progression. Carbon has 4 bonds, nitrogen has 3 bonds, oxygen has 2 bonds, fluorine has 1 bond. And the rule is shown here. When we're dealing with systems where the formal charge is 0 and the octet rule is obeyed, then the number of bonds just goes by where it is in the periodic table. Elements like carbon in the carbon column have 4 bonds. In the nitrogen column, the pnictides 3 bonds. In the chalcogens, 2 bonds. The halides 1 bond. And of course, the noble gases 0 bonds.